And that's good. Right. Okay, let's go. All right, welcome back. This is EST 102 and this is lab 8. And in this lab we will test the transformer ignition, which is ignition transformer. It's a wound up, the heavy one, or we either will have the lightweight one, which is called the igniter. So we'll go through the process. So this is the transformer. It will be mounted on top of the boiler, of the bearing, just like so. You can take it out because it's very heavy. Sometimes if you tilt it backward, it kind of maybe it'll break the hinge. So before you perform the lab, make sure you have your alligator clips. These are the alligator clips, a multimeter. You might need pliers or screwdriver to take the transformer out, and the transformer tester. So if you're going to be working on oil burner for kind of a long time, it's good to invest in one of these because they can measure up to 10,000 volts. These ones are only limited to 600 volts. Any more than that and they will burn. Okay, so that's a tester. And electronic transformer testers, we don't have any of those, and it's good to consult the manufacturer to see what will work. For the electronic igniters, either they work or they don't. So we do not test them for longevity or whether they give us enough voltage or not. They either work and give you 14 voltage or they don't at all. With these, they might work, but they might give you very high voltage and it declines with time and so on. So it's really important to know how much voltage are we getting out of these. Okay, so let's start. If you look at part 1, we are using a wind-up transformer. I mean, it's the heavy one with the copper inside. We take it out apart from the burner. Then we can use alligator clips to have it tested. And the first way to do it is to try to make sure it is connected. Make sure those sleeves do not touch each other. And this thing is pretty heavy, so make sure you place it correctly in it and be ready for the reading. So I'll turn it on, see how it sparked a little bit. Actually, I'll turn it off. First, I'll place these on the lead and I'll turn it on. As you can see, it's stable at 10,000 volts exactly. Okay, so this is the best and easy way to test a transformer if you have this big piece of machinery. If not, then you will move on. So here we got right on the spot 10,000 volts. Okay, so method 2, you place a transformer disconnected. You don't need any energy for that, and we will use our multimeter on the resistance reading, the ohm meter. And what you would do is, using the multimeter, measure the resistance from each prong. These are the prongs, so we'll measure the resistance from this prong to any casing. Usually they have a ground in here, so I measure the resistance from here, and it's showing here, as you can see, 11.82, and you will record that. I measure from the other side, 11.14, and I will use the calculator to get the percentage of these two. And in here I will divide 11.14 divided by 11.82, and they are about 6%. So this is 94% of the other, so they are about 6% difference. Anything more than 10% is not good. 6% is okay. That means still the winding is very good. Okay. If the difference is more than 10%, then the transformer is not up to standards, it's a little bit lower. 7, measure the resistance of the primary winding. So this is the primary because it's giving us 110 volts. So we'll measure this to the primary. And I'm getting 3.9 ohms. We got 3.9. It should be 3 ohms. Within 10% it's okay, so this is a little bit too high. 10% out of 3 ohms, that should be 3.3, so it's a little bit on the high side. So we can tell that this transformer has been used for a long time. Measure the resistance from the secondary winding. So for this one, it's giving me 23,000 ohms. 23K, and it should be 12 kilo ohms. But I think with this winding, it was supposed to measure only one side, which is around 11.9. So it's, I think, from each prong, not from it completely. So I think we are within range, which is 11.19. So it's within 10% of 12 kilo ohms. So we know this transformer is old, but it is not completely up to bar. But we want to see how much life is in it and how long will it function for. So for now, well, this is a pass. Let's test it again using method 3. In this method, we'll bring the gap in the transformer prong to about half an inch, which is 1 centimeter, and we'll use the alligator clips. And you will put the multimeter on the amperage setting, the lowest one, which is 2 amps. You clip it in one of those. It should be measuring 0. It is measuring 0 now. So I'll turn it on. I'll look for 2 things: color and amperage draw. I'll record that as soon as it turns on. And also need to have a watch handy. Okay. So the amperage draw is 1.75. The color is fluctuating because of the AC. So you see it's fluctuating between purple and orange, but it is jumping between the prongs, and it's still at 1.75. So in the lab, we'll leave this for 10 minutes. We'll keep it on, watch it for 10 minutes. Then we'll record the aftermath of the amperage draw and color. So the color, you want it to stay in the purple, not blue. If it turns to orange, you know that this transformer is getting weaker with time. The reason being is as it heats up, it will have more resistance, and that will affect the way it performs. And if the color turns orange, it means that it doesn't have the right temperature as well. The temperature between those 2 prongs should be around 600 degrees or so if you measure with an infrared gun. So let me look for now. It has been probably 2 minutes or so. It is dropping to 1.73. We can wait a little bit longer, like 10 minutes, and see how much is the amperage draw. But for now, let's say it's around still 1.75, you know. It's fluctuating to 1.72. So I'll turn it off and say the color is still orange, purple, and the amperage draw is 1.72. And again, I would love to see what is the percentage. And when I do the percentage, I usually divide the small number, 1.72, over 1.75, multiply by 100. So I got minus 100. I got 2% change. So that is not bad. So these are the 3 ways to test the transformer. Again, if I leave it for 10 minutes and you see a lot of fluctuation, you know that this transformer is weak and need to be changed. And this is how we test a wound-up transformer. So how do we test the electronic one? So the electronic ones, they're either on or off. They have an integrated circuit inside with solid state, so it does not really change resistance. and it's supposed to give you around 17,000 up to 17,000 volts. You do not test those with a tester. They're either on or off, and it's really hard to put a clamp on it to see if it's on or off. So we pull out those prongs in here, and we try to jump the spark between the two prongs. Keep in mind, in some manufacturers like Beckett, they say it's okay to do that, and some manufacturers, they say if you touch the prongs to each other, they will burn. I mean, it will burn the processor. So I'm going to touch those together, and I'll try not to touch them completely. I'm trying to get closer to just jump the spark between them. So let's see how that goes. It'll jump by itself. So we know that this thing is completely running, even though it's more than half an inch. It already jumped. So either it works or it doesn't. It's either going to give you 14,000, whatever it gives you, or it doesn't. So that's very simple. The difference between those two is this one is very rugged and it lasts for a long time. And from a lot of manufacturers, they say the electronic ones tend to break faster, and a lot of people are switching back to wind up. But it depends on the longevity of these. And this, the smaller electronic igniter, they consume less energy. But now with having interrupted ignition, it does not consume energy anyway. So this is part 2. We did check the spark, and either it's there or it's not. And make sure again those things are touching the leads inside. Okay, for the questions, what could reduce the life of a transformer? As we said before, the transformer is basically an iron core with a winding inside of copper wire, and this copper wire is insulated with tar. If the tar deteriorates, it will change the magnetism. So make sure you insulate that correctly. It's insulated with tar, so heat can melt the tar and change the magnetism, or if it gets water in it. So water or excessive temperature. What does the color of the spark indicate? Blue it indicates temperature. So blue is what we're looking for. It's around like 600 to 800, and orange is around 500 to 400, I believe. So it indicates the temperature of the arc between two prongs. Why would the amperage change after leaving the transformer for 10 minutes on? It will change because the transformer starts to heat up, and as it heats up, the resistance will change, and that will change the magnetism inside the wire. Could you use the same 3 methods on part 1 on transformer on a transformer for electric igniters? No, the electronic igniters are very finicky in how it's built, so you can only turn them on or off, and again, they break very, very often, so you cannot use the resistance because there is nothing to measure between those two prongs. It's an electronic circuit board. What is acceptable voltage for the secondary winding? For the secondary, which is in order for the spark to jump through air, it has to be at least 10,000 volts. Anything 10,000 and higher should be is recommended. And again, it's one of the most frustrating aspects of having delayed ignition. Sometimes the spark jumps into the casing. The casing is metallic, so make sure that those prongs sits in the correct location here on these electrodes. And we'll do a whole lab about setting electrodes. See those bars over there? You want those prongs sit neatly snug on these leads. All right, thank you.